Today's screencast is about gun crimes, an introduction to ballistics and how guns work. Ballistics is the science of projectiles, how things move through the air, through a fluid. Ballistics evidence includes firearms, bullets, and their cartridge cases. Different types of evidence that's searched for: bullet holes and damage, body wounds, and trajectories, the paths of bullets. You saw that in the CSU episode. There are three main categories of ballistics: internal, external, and terminal. Internal ballistics evidence looks a little bit like this. It's all processes that are occurring inside the firearm when a shot is fired. Microscopic exam and comparison of fired bullets and their cartridge cases is really, really important. This is done using a comparison microscope. Here are some pictures of what that looks like. So this is the bullet. This is what comes out of the front of the gun, hits a target. This is a cartridge. The cartridge either stays in the gun or is ejected using an automatic ejector and extractor mechanism. It's what the bullet is housed in before it exits the gun. Firing pin impression is on the butt or the back of the cartridge here. The firing pin comes into contact with a primer. Primer ignites and causes gunpowder to explode. So the firing pin impression can be analyzed. We have metal on metal contact. The bullet and the cartridge are both made of metal, and the firearm is also made of metal. So what we look to compare is the scratch marks, which we call striations. The scratch marks or striations are the ones that, if they match, that means that the two bullets or the two cartridges were fired from the same gun. That firearm will leave the same striations, the same unique pattern of scratches on any bullet or cartridge it comes into contact with. When we're looking at bullets, the caliber number is directly related to the diameter of a barrel. So a .22 caliber gun has a barrel that's 0.22 inches in diameter. A .45 is 0.45 inches in diameter. Bullets are projectiles, like I said. They consist of lead, tin, antimony, and copper, and they're surrounded by hard metal. Bullets will break up or mushroom on impact. Then you have the cartridge. The cartridge consists of a case, primer, and powder made of brass. It wraps around the bullet, and it's illegal to take others' cartridges. This is a picture of a cartridge and a case together. A cartridge and a bullet together. The bullet's made of lead. It's a softer metal that's up in the front. And then you have a brass case behind it. If you take a cross section there, you have smokeless powder inside the brass case, inside the cartridge, and then the primer mixture is at the butt, at the back end of the cartridge. There are three main types of firearms. You have handguns, which can be handled with the hand. You have rifles, which are longer range and you have shotguns, which are short range. When a gun is fired, there are different clues that are left behind. Piece of the bullet, a casing, the weapon itself can be left behind, bullet holes, and gunpowder residue. As I said before, bullets, casings, and fragments all have unique patterns called striations, those scratch marks. Here's a cross-section of a firearm. You can see what's going on here. The process that goes on inside a gun when it's fired, once that trigger is pulled, the hammer here springs forward. At the other end of the hammer is what we call a firing pin. That's right here. The firing pin strikes the primer at the butt of the casing in that bullet. The primer ignites under pressure, and then that in turn ignites the gunpowder in the cartridge. The gunpowder explodes, and that air pressure, the gases that are produced, propel the bullet out of the barrel. Inside the barrel, there's a bore, B-O-R-E, that's made of what we call lands and grooves. Lands and grooves are spiraled. They force a bullet to rotate or spin as it travels, making its path straighter and more accurate. Again, that metal-on-metal contact of the bullet against the barrel of the gun, and specifically here against the lands of the barrel, will cause those scratches. And then under the microscope, the scratch marks can be used to match the bullets to the gun. So what you see here is a cross-sectional view, as if you were looking down the barrel of a gun, and you see the spiral lands and grooves. Here's a longitudinal section. If you follow one groove here in red, and another groove here, another groove here, you see that spiraling, spinning pattern. Really important to know, marks are not made on shotgun pellets. The barrel of a shotgun is not rifled. Shotgun pellets are in a shell and they're made to create a wide spray. They're not targeted specifically. They're supposed to do lots of widespread damage, so they create a wide spray instead of a single pattern of injury. Marks on the casings and the cartridges come from the firing pin, the ejector and extractor mechanisms, and the breech block. It's a little typo here. This should be breech block. IBIS, Internal Ballistics Identification System, is the database, just like we talked about with fingerprints. It's AFIS. IBIS is the computerized database to collect and compare striations on bullets fired from different firearms. So that was all internal ballistics. External ballistics is the study of the bullet's path from the moment it leaves the muzzle of a gun's barrel until it strikes a target. It's calculations of trajectories. You saw that in the CSU. They were putting the rods through and putting the lasers on the end of the rods to figure out the actual path of the bullet. We saw this in the video also about JFK. How did this bullet, this what they call the magic bullet, go through and turn and do all that craziness? Then finally, terminal ballistics is the effect on the target. You can determine firing distance between the bullet and the target, or sorry, the gun and the target, and it establishes whether a wound was caused by a particular bullet. You can figure out the caliber and the type of the projectile as well. And you can identify exit wounds, and more importantly, what we'll do in class is examine gunshot residue, which you see here on this shirt. Gunshot residue, you can see here, is coming back away from the gun. That's going to be deposited onto the person's hands. Gunshot residue, or GSR, is gas, metal bits, and chemical dust that exit the barrel of the gun with the bullet. That can go forward. I think I said it wrong in the last slide, but primer residue goes backwards. GSR rings, you saw in the CSU, they were looking at that. The size of the residue ring tells how far the weapon was within 3 feet. Larger rings is a farther away shot. Smaller rings is a closer shot, closer to point blank. Testing for the presence of GSR includes swabbing the surface with an alcohol prep pad and then adding a special GSR solution to that pad and watching for a color change. We'll do this in lab and you'll be able to see how that works.